Let's take a look at selective precipitation. Selective precipitation is a technique that's used to separate two cation or two anion in a common solution. So the way to do that is to precipitate one of the cation or anion, leaving the other in the solution. In this example, we're going to run through is that we're looking at two cation in the solution, Ag plus and Pb2 plus. And we will be adding Cl minus to precipitate silver chloride and magnesium chloride. The technique to solve such a question is to build a solubility ladder. Let's take a look. So in this ladder itself, we have the concentration of Cl minus increasing from 0 and all the way up. So the first step to do is to calculate the concentration of Cl minus that will allow PbCl2 to be precipitated. So in these questions, the concentration of your Pb2 plus is 0.005 mole per dm cube. We can calculate that the minimum concentration for Cl minus to force the precipitation of lead-2 chloride is this value. Let's do similarly for silver chloride. For silver chloride, the concentration for Ag plus is this value, which is 0.015, and via the calculations, we can conclude that the concentration of Cl minus to force AgCl to be precipitated is this value. We're now going to plot both this value on the solubility ladder. In the case of silver chloride, it will get saturated when the concentration of Cl minus is here, and beyond this value, AgCl will be precipitated. In the case of lead-2 chloride, the concentration of Cl minus needs to be higher in order for it to be saturated, and beyond this value, it will be precipitated. By plotting this value on the solubility ladder, we can conclude to say that we will want to add the concentration of Cl minus from 0 until this value. Because at this value of 0.0566 mole per dm cube, only AgCl is being precipitated, and PbCl2 is saturated. So through filtration, we could actually extract the Ag plus in the form of AgCl as a residue. From here, we're able to calculate the maximum amount of Ag plus that's been precipitated. We could do so by using the KSP of AgCl. Since the maximum concentration of Cl minus is 0.0566 mole per dm cube, we could input that as the concentration of Cl minus in the KSP expression for silver chloride. And we can work out that the concentration of Ag plus that is saturated and still in the solution is this value. And from here, we are able to determine the amount that's precipitated by subtracting the concentration of Ag plus, which is the initial value prior to adding of Cl minus, subtracting away the concentration of Ag plus that's still in the solution. So from these calculations, we're able to conclude that the concentration of Ag plus, which has been precipitated, is 0.015 mole per dm cube. That value is actually about 100% of the concentration of Ag plus that's in the solution initially. So from here, we can conclude that selective precipitation using this technique is highly effective.